This is section 3.4, truth tables for the conditional and the biconditional. We are going to be adding 2 truth tables to the 3 we already have. We have conjunction, disjunction, and negation. So let's think about a conditional, which is if P, then Q. We're going to look at this example and talk through it. If our P statement is it is raining, and our Q statement is I will bring my umbrella. So our general conditional written out in English would say, if it is raining, I will bring my umbrella. When we're going to make a truth table for the conditional, what we need to think about is think of the first statement as a promise, and then use the second statement to decide whether or not the promise was broken. Okay, so if the first statement is true, and the second statement is true, so if it is raining, and that's true, and then I will bring my umbrella, if that's also true, then I have not broken my promise. It is raining, and I brought my umbrella, therefore the promise is kept. Okay, now our second line. If the first statement is true, so it is raining, but our second statement is false, I don't bring my umbrella, that overall statement is false because it is raining and I didn't bring my umbrella. The promise was that if it is raining, I will bring my umbrella. It is raining, the first part of it's met, but I didn't bring my umbrella, I broke the promise. So that one's overall false. Now the tricky part, I mean, most people can get those, think through those, but the tricky part comes in here with the false statements in the beginning. Both of these are true. It does not matter whether the Q statement is true or false. So if it is not raining and I brought my umbrella, I haven't lied because I promised nothing about what I would do if it wasn't raining. Okay? And here, if it's not raining and I didn't bring my umbrella, there's a typo right there. I'll try to fix that and then up on the one I uploaded for you. It is not raining and I did not bring my umbrella. Brought, I'll fix all that. So nothing was promised about what would happen if it was not raining. So it doesn't matter whether I brought my umbrella or not. Same thing. Nothing was promised about what happens if it's not raining. Nothing is broken. Okay? So in other words, the only time the conditional is false is when the antecedent, which is the sufficient part, or the first part is true, and the consequent, or the necessary part, is false. So in symbols, the only time a conditional is false is when it looks like this. True, if true, then false. So I've just recopied our truth table here for a conditional, which is this first part here with leaving off the reasoning. Okay, this last bit right here. Note, you can always reverse a conditional if you negate both the antecedent and the consequent. That is, you can always change if P then Q to if not Q then not P. This is something that's going to play a big part in the next section, and we're going to be coming back to that quite a bit. Okay? So, we're going to construct a truth table for the following statements. So here I have if P then Q and not P. So just like we did before, we are going to build up each piece that we need. And I look through first, I look for the simpler statements and I have a not P, so I'm going to figure out not P. So since P is true here, this would be false. This is false, true, and true. Okay. Now I need if P, then Q. Okay. This is our conditional. Exactly. I mean, there's nothing added here, nothing changed at all, and these are always in the same order. So what we have is if true, then true, and that is true. If true, then false, that's the only time it is false. If false, then true, that is true. If false, then false, that is true. Okay, so now we have this piece and we have this piece. Now we need to AND those and we will be done. So we have if P, then Q, and not P. So this is AND, which is conjunction. And the only time a conjunction is true is when they are both true. If there is a false in either part, then the answer is false. So let's look at this. I have this piece, and I'm trying to AND them together. Well, there's a false, so that would be false. False and false. Both true, so that's true. And both true, so that one is true.